myself Dr. Lavin Kumar Bagi, and now I am going to discuss the assignment for group 2. And very first question over there is what is EOQ, and then write the expression for economic order quantity when instantaneous supply continuous consumption is there with reserve stock. This is the important part over there. Here we discuss the reserve stock over there. And what is the difference between all these things? AB inventory control techniques over there, ABC, FSN, and VAT over there. EOQ I have already discussed you in the previous lecture. You can go to see my previous video for this EOQ. And now I am going to here discuss that drive the expression for economic order quantity when the instantaneous supply continuous consumption with reserve stock is there. In this case, you can see from this graph over there, there is a Q value over there, Q is there, and the reserve stock we put, or we can say safety stock we put, is the R over there. That means that you can see from this point, up to this point, how much quantity now we have over there. This is the maximum, that is the Q plus R. This is the maximum inventory, and the minimum inventory always we have is the R. This is the minimum inventory over there. So the Q is the economic order quantity, R is the reserve stock or the safety stock over there. Q plus R is the maximum inventory, R is the minimum inventory, AB is the cycle time, that is the first order and the second order, we can say, and CS is the shortage cost per unit per piece, D is the annual demand over there. From here we can see that when we calculate the average inventory, that means maximum plus minimum by 2. This is the average value we can easily calculate, but in this case this is the maximum inventory Q plus R, and this R is the minimum inventory we have in hand. That means it becomes average inventory we have Q by 2 plus R. This is the average inventory, and now we are going to see what will be the total cost of the inventory per year. And when we see the total cost in the inventory, then ordering cost, carrying cost we generally include in this equation over there. First we calculate the ordering cost, then we calculate the carrying cost over there, then we sum up and solve the equation. Now we'll see what is the your ordering cost over there. Ordering cost is basically that the demand upon the your Q quantity into C0 plus this is the average inventory and into the carrying cost per unit per year over there. We can solve this equation over there. Now the value of R. Now the value of R we do not know what is the R value, but it is assured that R is be the fraction of this value of Q. That means, so that's why we write R is equal to some value of fraction into Q. That means F can be, suppose I put 1 by 2, R is equal to 1 by 2 Q. We can write in this way, R can be 1 by 3 into Q. That means F, any fraction value over there. So we put F into Q and replace with the R over there. And so your total cost equation now becomes in this way over there. And now we know that whenever the total cost we have calculated, whenever we are going to calculate the Q value, we generally differentiate this DC upon DQ, and this equate equal to 0. So we can calculate the value of the Q. What will be the optimum number of units we are going to place in an order? And for this equation we have, now we do the derivative, put this equation derivative equate to the 0, and we solve this derivative, and after this we can get the equation in this form over there. Okay, and then at the end Q is now in terms of this equation, and we can easily see that Q now becomes 2dC0 upon CC1 plus 2F over there. So we can write this thing. This is the optimum quantity of the units per order for the model which is having the reserve stock of the inventory. So this is how we can solve the equation over there. And then we have the difference between ABC, FSN and BED inventory. This I have already discussed in detail in the previous video. You can go to that video and you can see all these things in detail. Now I am going to discuss the question 2, that is the a supplier has to provide his client with the 12,000 units of his product every year. That means this is the demand over there. The consumption is constant and known. Subsequently, the item is used in an assembly and there is no shortage. Because the item is used in assembly, that means we do not want to be a shortage over there. And in case supplier not supply the essential item, the shortage cost is rupees 1 per unit per month. This is the shortage cost. If it's there, the inventory cost is this. It is given, that is the rupees 0.50 per unit per month over there. The setup cost, that is the ordering cost, is given, that is the 700 rupees over there. We have to find the optimal quantity, the optimal level of the inventory at the beginning of any period, optimal scheduling period over there, minimum inventory cost over there. So these are the things we are going to find. Now let's start with this. That is the D is the annual demand per year, that is 12,000 units. Ordering cost, that is the 1700 is the ordering cost, it is given. Shortage cost, it is already mentioned, but this is in months over there, so we have to convert this into the years over there. So multiply with the this 12 over there, we can get the shortage cost in year. Similarly, carrying cost is given in the month, so we convert into the year. So multiply with that 12, we get 6 rupees per unit per year over there. So this is now all the things are year over there. Now for this case, for the shortage, when we allow the shortage, that means formula we already know. There is a formula 2dC0C, and for the shortage CS plus CC upon CS. So demand we know, ordering cost is given, and shortage cost is already mentioned over there, and carrying cost, it is mentioned over there, that is the 6, this is 12, shortage cost, all the things that we mentioned. So we can easily get the what is the optimum number of units we are going to put in an order over there. So the number of units is 3,194 units are there in an order. In single order, we have put this much number of units over there. So this is the value of Q over there, that's the optimal value of Q. Next we are going to find the optimal level of the inventory at the beginning of any period. Now as we know, in the case of you can say shortages are there, so at the beginning of any, the number of this is the from here the consumption is going on, and at that point the inventory goes to 0, and then you take the back orders over there for this much number of units, and whenever you get the total inventory over there, you are going to first provide the customer who's already been put the order in advance over there. That means the rest of the quantity is now in the inventory is this. That means Q minus S is the quantity which is in the inventory over there. And S we already know, that is the shortage part over there. Short units over there, that is the Q C upon CS plus CC. This we already calculate in the uh, previous class over there, that is the Q previous lecture over there, Q CC over there, and then Q minus S, because we need to know this thing, because this is now linked with the inventory over there. That means Q we know, S we already calculated and put the value over here, and this is the value of S. Then we solve Q minus this value, and we can get Q minus S is this. That is the Q CS upon CS plus CC over there. So only term replaced over here is changing CC, that is the carrying uh, cost with the shortage cost over there. So this becomes Q minus S over there. And this Q minus S, I have already told you that I have mentioned this IM, that in the IM is Q CS. This we have already find that, and we have put the values Q we calculated, shortage cost is given, and this week shortage cost is there, and carrying cost is given, so we can get the Q minus S over there. So this is the value is IM value. Now the optimal level of the inventory at the beginning of any period over there. This is the value over there. So this is the optimal value of the inventory should be this value. Okay. For this we can this number of units we have to not store, or we cannot keep in the inventory over there. So the level of the inventory is generally defined by this Q minus S. This thing I have mentioned over there, the remaining quantity, that is IM is Q minus S, is placed in the inventory as surplus to satisfy the demand in the next cycle. Note that S units out of Q are always in the shortage list, that is they are never placed in the inventory. That this thing I have already told you that S we are not going to put in the inventory, because this thing is going to compensate the back orders over there. Okay. So this is the optimal level of inventory at the beginning of any period. Next we are going to find the optimal scheduling time. That means the basic scheduling time is nothing but the cycle time, and cycle time we already know that it is the Q upon D. And if I write the D upon Q, that means the number of orders in a year. If I put Q upon D, it is the cycle time. So over there cycle time is 3.94 months. That means one order we put over here, and after 3.94 month we put the second order over here. So this is basically the cycle time over there. The minimum inventory cost now we are going to find, and for this minimum inventory of the cost, Q optimum we know, and IM we already find. And in the case of IM over here, it is Q over there. Now we replace this Q with the value of this, and we can write Q in terms of this value, and after solving this IM, we can write IM is in this form over there. That is the 2D C0 CC CS upon CS plus CC. So this is the additional uh, values we can see over there. Additional cost we can say. So this is the Q optimum. This is the IM value. IM is nothing but Q minus S value over there. So this is the value we can see over there. So minimum inventory equation we already know. This is the minimum inventory equation, and after solving this equation, now Q minus S we know, and Q value we know, and you put all the values, S value we know, so we can solve this equation. And after solving this equation, we can directly go to this equation, that is the minimum cost inventory cost in the case of shortages are allowed over there. So we can put directly over there. Now D value, demand is there, ordering cost is given, carrying cost is given, shortage cost is given, all the things are to be mentioned in the problem. So we can easily find the minimum inventory cost in this case, and comes out to be 12,774.97 is the minimum inventory cost over there. And in this question, that is the Hayes electronic stocks. This question I have already discussed in the previous lecture over there. You can go to see that lecture over there. I'm going to discuss with you the last question of the assignment, that is question 4. Computer shop wants to reduce a large stock of desktop computers. The owner has offered the college a unit discount pricing schedule in case of the college will purchase the desktop computer in large numbers. And this is the discount pattern is given, that is if he purchasing the 1 to 49, the price for the particular computer is 15,000, and if he is going to purchase, put the order of units 50 to 89, the cost will be 12,000, and if it is going to be more than 90, the cost is to be reduced to 10,000 over there. So this is how the price is going to be decreased by every when you put more number of orders, more number of units in an order. The annual carrying cost for desktop is 200. The carrying cost is given, the ordering cost is given, and the annual demand it is given over there. The college wants to check whether it is better to take the advantage of this discount or order the basic EOQ order size. So we have to find first the basic EOQ, and then we have to compare the Q value from here, and we are going to find the Q value from this discount model, and then we have to compare these two values of Q, and then we find the TC value for these two values of the Q value. And now we can see how to solve this numerical. Now first we have to find the Q value based on the basic EQ model. Basic EQ model we already know. This is the basic EQ model, and from here the value of the number of units we are going to get is 77.5 units over there, and based upon this number of units in an order we find the total cost, and total cost comes up to be is this value. Now the main thing in that case is we are going to add this new term, that is the PD value. P is the per unit price of the item and D is the demand over there. That means how much product cost is there. That means if I going to suppose 100 units are there, and every unit is having the rupees 10 rupees, that means total cost of the products is comes out to be 1000. So this is how we are going to get the product cost, total unit cost over there, you can see. So this is the total cost, this is the ordering cost, this is the carrying cost, this is the your material cost over there. Okay. Now from here the demand is given, Q we have calculated based upon the basic EOQ model, ordering cost is given in the numerical, and we put all the values. This is the product cost per unit over there, and demand we know, and product cost is given. You can see over there the so over there you can see for this 77.5 units over there. When we see this much number of units, then in which bracket it is going to lie? 77. That means in this bracket. In this bracket, that means 7.5. Number of units we are going to order in. Number of units we are going to put in an order. If I put this much number of units in an order, what is the price of the unit is? Price of the computer is 12,000. That means this is the product price, and how many units we are going to buy? 300. So that's how we get the material cost or the total order cost over there, which is going to be That is the 36 3,06,000 over there. So over there we can easily solve this one. So we put this is the product cost over there, and this is the number of units we have in demand. So from here the total cost comes out to be this value. That is the huge value we can see over there. That is the 36,15,491 rupees over there. Okay. Now we can see what will be the total cost if we order more than 90 rupees. Okay. So we take that 90 value over there, and product cost we now take that 10,000 over there. Now for this I read for you. Because there is a discount for an order size larger than 77.5, this total cost comes up with this value must be compared with the total cost with an order size 90 and the price 10,000. Now we solve the total cost. Keep in mind that 90 number of units in an order, and product cost is now we have to pay 10,000 rupees. And with this Q now replace, not we use the 77, now we use the Q as 90. When we use the 90 over there, that means product cost comes out to be your 10,000 rupees. Rest of all the things are to be same over there. Now you can see we replace Q 90 over there, Q 90 over there, and rest of all the things are to be same. And then we compare this thing. The total cost comes out to be 30 lakh. So earlier it comes out to be 36 lakh. Now it comes out to be 30 lakh. So it is good to go for the number of orders, the number of units in an order with the 90. So we put 90 computers in a single order to get the discount over there, price discount over there, because your total cost comes out to be very less over there. So because this total cost is lower, the maximum discount price should be taken and 90 units put in an order over there. So with this the solution of the assignment is